Okay, we're going to look at something called a horizontal shift with functions. And then we're going to look at that horizontal shift in the context of circles and hopefully kind of move on from there to get a better understanding of getting some marks in the circle part of the the metric exam. So let's just take a look at this. So look at this. We've got f of x equals sine x. The basic sine graph goes from 0 to 90 and 1, 180 and 0, 270. And there's our basic sine graph. Now, if you get another function, say g of x, where you're going the sine of x minus 30, so that'll give you a new function. And that new function there is going to be this function right here. I'm labeling it g. When you see minus 30 degrees here, what it does is it takes every angle and it shifts it 30 degrees to the right, the opposite direction that you think. Well, if you think about it, it sort of makes sense. 0 and 0 is an important part. It's where sine waves start from, 0 and 0. But if in this x minus 30, if I put 30 in there, I'd get 0. So if I just move over 30 degrees, I should get the same answer. And if 90, if I just move over 30 and get 120, 120 minus 30 would be the same as 90 degrees. In fact, every single point of the sine x function moves 30 degrees horizontally to the right. You know, with the function when you see x minus 30, it moves in the opposite direction of where you see the number there, minus 30. And you know, all functions work like this. Inside a bracket, it works the same way. You can come up with a general solution that when if you subtract a number, if you go f of x plus h, if h is negative, you go that many units to the right. If it's positive, you go that many units to the left. Well, let's take a look at this basic circle. The most simple and basic circle you can look at is x squared plus y squared equals 25. And if you look at this triangle, 3 squared plus 4 squared equals this hypotenuse, which is the radius, 5 squared. So 3 and 4 is a point. You could see that minus 3 and 4 would work as a point. You could see that 5 and 0 would make this equation true. Any points on the outside sort of make the equation true. The center of this circle, though, is 0 and 0, okay, with x squared and y squared. But if we were to add 4, go x plus 4 squared and y minus 3 squared, we can use that idea we just learned. If we add 4, what should happen is the circle should shift 4 to the left, because minus 4 would give us the same thing of being 0. So it does, it goes 4 to the left. And we can use the same idea here. This calls a vertical shift inside the bracket here. If you see a minus 3, that's why the center moves up 3. The opposite of these numbers will be where the center of the circle is. You've got your equation. If you take the square root of that, that's really the radius squared. If you take the square root of that, you'll get the radius. Well, let's take a look at this here. If we had x plus 4 squared and y minus 3 squared equals 25, I want you to try something. Look at, if you go x plus 4 times x plus 4, you get x squared plus 9x plus 16. Do FOIL on it carefully. Make sure you see why that's true. Y minus 3 times y minus 3 will give you this. Y squared, the outer and inner products will give you minus 6y. And minus 3 times minus 3 will be plus 9. If I take 16 and 9, which is 25, away from both sides, I could write this circle in this form. X squared plus 8x plus y squared minus 6y. Still the same circle, but in a different form. You're often given this form and asked to change it into the form where you can find the center and the radius. So this is what you do. This is what so many people missed in the last paper. What you do is you have to complete the square. You have to look at that 8 and take half of the number that's in front of that 8 and square it. That's what you add. So you go half of 8 is 4, and 4 times 4 is 16. You add that, and you'll be able to, what we call, complete the square. Half of -6 is -3. Squared is 9. Well, whatever I do to one side, I do the same to the other. So 16 and 9 that I added is 25. And here's the big part here. This x squared plus 8x plus 16 can really be x plus, with a bracket, always again, half of the number that was in front of x. So it's 4. And then y minus 3, because you take half of the number that's in front of y, you put it right there, and square. There's the form of a circle now that you can tell the center. The center is the opposite of these numbers, -4 and +3, and the radius is the square root of this number. Hopefully this will help. And when you get questions like this and they say, okay, this is a circle, what's the center and radius? You can complete the square. This last example here is a bit of a fraction thing. It makes it a little bit harder, but hopefully you can get the right answer. I hope this helps, this idea of horizontal shifts and shifting and how to complete the square to figure out what the center and the radius of a circle are. Okay, well, that's it for today. Okay. Stop.